Hey, welcome everybody. This is Richard from Repair Room USA. I am here to teach you the very first lesson that we learned when we went to take the Ipadrehab practical board repair school. And I am going to be going every step. I'm not going to be able to make a video because it was an 8-hour day. So I'm just going to do section by section. This is the very first thing. Very first thing she taught you is a boot loop. When you have an iPhone and it's going in through a 3-minute boot loop, what is it doing? The phone is trying to turn on, but something is happening and it can't just quite make it there. So it just keeps trying. Something happens and then it doesn't get there, so it tries again, and it just keeps going through that cycle. Now, depending on the model, it could be something very simple, like some corrosion somewhere down the powering up of the phone that's not allowing it to be able to actually boot. Now, what is the solution for this? The solution for this is to go into the panic logs. Now, unless your iPhone has that boot loop on it, it's not going to give you a panic log. But the way to be able to do that is you go into settings, you go into privacy, you go into analytics, you go into analytic data, and then once you do that, you look for the very last, it's dated and there's a time on there. You look for the very last panic log that it gave you, and you go in there and it will give you a code. Now you get this code, and what do you do with it? Easy. You go to Ipadrehab. So let's show you here. So I would go into my computer. Let's do it from scratch. Go to Ipadrehab right here. All right. Go into the little loop. I would put in sensor. Go like that. Go to here. All right. This gives you an idea of sensors. Now your panic log is going to look something like this. See that circle right here? Missing sensors, mic. Okay. Now it also will give you a code. You can go into the codes, and depending on the series, they're going to be different. Now, can you depend on these codes? No. A lot of times when they change iOS, they're going to be changing these codes. But this can give you a general idea on what the code is and in what direction to look for your fix. So that gives you a starting point, a reference on what to do. And what is the easiest way to be able to find out if it's actually something else on the phone and it's not the motherboard? How do we rule out variables? Easy. That's why I told you in the last video that if you're going to be working on iPhones, if you're working on an iPhone 6, for example, some customer brings it in, then that means you need another iPhone 6 that's working 100%. Okay, so if I have one that's working and I have one that's not working and I don't know what it is, I will take the motherboard out of the one that's not working and I put it in the working housing of the one that I know. And if it boots up, now I know it's something external from the motherboard and I can roll that out. That's why if you're working on iPhones, it's very important that you have a working phone, and that will help you tremendously for being able to diagnose a phone. So the very first we did in class is we imagined if we were going to build a device, okay? We were going to design a device. What would we need for that device to actually work? So the first thing that we said is we would need some way for our device to get power. Now on a phone, that is either the charge port or the battery. And then this is some very handy sheet that they gave us in class. All right. And it says it right there. Battery, 4 volts. Charge port, 5 volts. So we need something in the phone, something in whatever device that we're getting for it to get power. Now, what do we do with that power? We have to get that power, and we would need to have some kind of charging chip or something to give us the charge to make it go into the main power rail. So we would need something that's going to give us the main power rail of the phone, all right, which is usually 5 volts, and that is going to go into the heart of the phone, which is the power management unit, which is the power management chip. So we were designing a phone that would be the starting place that we would need to design into the product that we're making. And she also gave us an example. If we were to get a battery, okay, it's a 4-volt battery, and we were to test it. If it said it was 3.8, that means that battery is low. A full battery would actually test around 4.2, 4.3. That is a full battery. Now, we're designing a phone. We need to get this main power rail to be able to give power to all the different components. What are the different power voltages that we would need for our device? We would have to power the CPU, for instance. Now, CPU, if you were to give it 5 volts, what would it do? It would fry it. So CPU requires 1 volt. The power button, it's 1.8. The NAND, 1.2 or 1.6. So different things require different voltages. For example, an iPhone 6, okay, it would have an LCD backlight, and it would require how much? 23 volts. That's a lot more than the 5 or the 4 that we're getting in. How do we get 23 volts? Coils. Coils are this invention. This is basically these wrappings of wire. When we do that and we provide electricity, it generates a magnetic field. So with any power system, with any device that we're designing, we are basically manipulating the electrons to do what we want. So we can actually boost the power, and that would boost IC, that would be its job, to boost the power, to add the lines and the different voltages that we're going to need to power the different systems in the phone. What is voltage? What is electricity? What is voltage? And she gave us a very good explanation on voltage. And voltage, think of it like this is a balloon, okay? If voltage is pressure, all right, that's all it is. Voltage is pressure. So I would get this wire, and I would put voltage in it, kind of like a balloon. I would put voltage in it. What would happen? That balloon, okay, now it's 3.8, 3.9, 4 volts, 4.1, okay, I'm adding more voltage, and if I would leave that in there, it's not going anywhere. It's inside my wire, it's inside my system, my circuit, my balloon. If I were to leave and come back an hour later, that would still be 4.2 or whatever it was. If I were to go and make a trip and go around the world, maybe I would come back and it'd be 4.0. It would lose, just like a balloon would, it would lose a little bit of its voltage in there. Natural for it to do. So when you hook up your phone to a charger, there is like for example, for the USB charger, there's a conversation that goes on there, and it's going to say, hey, listen, I need 5 volts. Or some systems, hey, I need 9 volts. And that's something that the USB has a conversation with the adapter and say, hey, this is what I need, this is what I require. So remember, the PMU is the heart of the device. Now, there is power and there is data. Data and power is separate. Now, what is data? We all know that data are basically a series of ones and zeros. So we can't have all these systems powered on all the time. You know, it would waste electricity. So when your phone is off or the system is off, it's always listening. There's always one power line in the phone that's going to be on at all times. And what is that? That is the power switch, the power button. That is 1.8 volts. So if I were to go into my phone, okay, and I would find the power connector, okay, where the power connector connects, and I would to test there should be present 1.8 volts. And you can do that, and you can actually go in there, and you can test it, and you can find 1.8 volts. Now, what happens when we actually push that button? When we push that button, we are actually grounding it. And in most systems, that's how they work. When we push the button, we are grounding it. Now, what is ground? Ground is what electricity wants to go to. Electricity wants to go to ground. Ground is like a black hole. When a system goes to ground, it goes to zero. So remember, data is ones and zeros. So if we want to communicate with something, we can use grounds to produce zeros, and we can use voltages to produce ones. Okay, so if we're designing some kind of chip, we need to have the power button to be able to wake up the rest of the system when we actually push the button and ground it, and we're telling the system, hey, somebody pushed the button, now we need to do something. So just think of the power button as a doorbell. When you hit the doorbell in the house wakes up and everybody's like, oh my God, somebody hit the doorbell, we need to go find out what's going on. So basically think of it like that. So if we are designing a system, we have to have a place to be able to store the information once that power button is pushed. So what does the PMU do? It goes to the NAND. Now the NAND is where all your pictures, all the software, all the low-level boot order is at. Between the CPU and the NAND, and those two communicating, and that tells the instruction set is located here. Now in iPhones and in most devices nowadays, that information is encrypted. Now, if I had the most powerful computer in the world, could I unencrypt that NAND? The answer is no. It would take lifetimes, generations for it to be able to unencrypt that. In the old days, it was very easy because that part of the chip was inside the actual CPU. Now the CPU talks to a lot of other devices, so it was very easy to be able to hack it and to be able to get and be able to encrypt the information that way. So what Apple did is they removed that whole system and they made it a whole separate thing, which is the EEPROM. Okay, the EEPROM is in charge of unencrypting the information that's going between the NAND, which is where everything is stored at, and the CPU. That encryption, the EEPROM, is in charge for that encryption. So when you get an iPhone motherboard, the most important things to get the data out of it, no matter what happens to the motherboard, is you have to have three things. You have to have the CPU, you have to have the NAND, and you have to have the EEPROM all working, and that all from the original owner, from the original phone, to be functioning, to be able to get the data out. So if something happened to my EEPROM or my NAND or my CPU, game over. Can't fix it. So we have a chip that's responsible for listening to all the different things, and it communicates. And this is something that they instilled in us, and they said that everybody forgets. It's a special chip called the I2C chip, okay? And the I2C has multiple channels, and it's the one that listens to everything. For example, it would have a channel 1, and it would say, okay, somebody hit the power button. You guys start booting up your low-level firmware, start turning on the screen, put up the Apple logo, okay, and let's get ready to go, okay? Channel 2, all right, you guys just chill out there, okay? I need to get some things, done before I actually tell you guys to turn on. So just hold and wait, and I will be with you guys in just a little bit. Channel 3, all your job is to remember this one thing, a code word, peanut butter. So that's all you guys have to do, and just stay put. When I ask you, and I'm going to ask you for that peanut butter, you guys, make sure that it's the right code, and we're going to be good. So that I2C chip communicates with various things in the phone. Now, when you get that Apple logo and it keeps booting back and forth, okay, it's that I2C chip that's asking for the different parts of the phone to say, hey, listen, somebody pushed the power button and let's go. So if you're getting the Apple logo and it's boot looping, what do? Well, you will go into the sensor logs like I told you. Somebody in the class said you would change the battery. Okay, change the battery, same problem, all right? Somebody else in the class said, okay, you would disconnect the proximity sensor. If you looked in the logs and they say, hey, listen, there's a sensor problem. And if You go into the phone and it's got multiple connections, that things that are connected to the phone. So if I disconnect the proximity sensor, which is something that's located usually right here on the phone. Have you ever noticed that when you put your phone to your ear, like the screen will turn off? Okay, that's a proximity sensor. It knows how far something is to the phone. And there's also like a front camera. There's a flood projector in there. There's a dot matrix. So that's how the phone does face recognition. It projects these infrared dots that nobody sees onto your face, and depending on the distances of the dots, that's how they know if you are who you say you are. Now, is that necessary for the phone to work? No, no. What's necessary for the phone to work? Like I said, you need to have some kind of battery or connection to the phone, all right? Some kind of power source, the CPU, the EEPROM, and the NAND. You don't need that. So if you disconnect it, boom. We did that, and guess what? The phone started powering on. So what was going on there? Let's just say underneath that connector, there's a tiny little bit of cat piss or some kind of corrosion from water damage, all right? And what it's causing it's causing a short. Well, now, what is a short? It's something that's being grounded out. Power wants to go to ground. So now the I2C chip is not getting that communication of the ones and zeros. What is it getting? It's just 0, 0, 0, 0, 0, 0. So if it's getting that 0, the I2C chip is saying, something is wrong here. Let's try again. And it keeps boot looping and boot looping. That's what's going on. So unless you either disconnect something that's not necessary and you eliminate variables, or you go in there and you actually fix the corrosion, you clean that out, that's the only way, and it's not grounding anymore. That's the only way that you're going to get that phone to power back on. Now, once we disconnect that proximity sensor, bam, phone powered on. That's great. So what that's known and what that's called is I2C corruption. So the I2C is like a group chat. You got all these different things that it's communicating with, and it's allowing the phone to talk to all these different parts, and that's for it to be able to turn on. And everybody forgets that. That covers pretty much the first 2 to 3 hours of the course. I will make another follow-up video and then show you what we did after that. Basically, that was the boring part of the class. Remember, I am Repair Room USA. I am doing a series of videos on explaining everything that we learned in the class, step by step, and a lot of it is just to refresh and also to pass down this knowledge. And remember, if you want to take the class, it's called Ipadrehab. It's in New York. It's actually very affordable, and there's no substitute to hands-on teaching. So please have a comment down there. If you have any questions, I'll be happy to answer them. My name is Richard, and I'll see you guys next video. Thank you.